Hello, welcome. Okay, so today we are going to solve KCET 2020 solved paper, and this is the fourth part. We have seen 21 questions so far. Okay, so if you have not watched the videos earlier, please first stay tuned there, watch the video and then get back to this one also. Okay, yes, so we are going to solve part 4 today, KCET 2020 mathematics solved. Okay, yes, so we go to the next question, that is the 22nd question. Okay, so the question number 22. So let's see what is there in this question. Okay, first let us understand this question. Okay, so let us understand this question. Now what is being given here is limit x tends to 0 tan x by root 2 x plus 4. So square root of 2x plus 4 minus 2. And they've asked us what is the limit of this equal to. Okay, so I repeat, limit x tends to 0 tan x by square root of, the square root goes only for 2x plus 4 minus 2. So what happens here? So here limit x tends to 0 tan x by square root of 2x plus 4 minus a 2. Now, first method in limits is, first step is direct substitution method. Always whenever you get a limit question, my first step is direct substitution method. Okay, so when I substitute directly, let us see what we will get. Okay, so therefore this will become what? So x is 0, x is going to 0, right? So tan 0, what is tan 0? Tan 0 is 0. Okay, now come to the root there. So square root of 2 into x is 0. So 2 into 0 is 0. 0 plus 4. Okay, 0 plus 4 is 4. What is the square root of that? 2. 2 minus 2 is outside. So again you are getting 0. So wherever you are getting 0 by 0 form, what comes to my mind? Okay, so that means this is not the determinant form, it is the indeterminate form. So how to proceed here? Either there are two steps, either I can take the rationalizing factor, the denominator, and then proceed, or the best way of choosing is using L'Hospital's rule. We call L'Hopital's rule. So how to use that? What is L'Hopital telling us? L'Hospital's rule, what is it telling us? You have to differentiate the numerator, differentiate the denominator. That is what L'Hospital's rule is telling us. Okay, yes. So let me differentiate the numerator and differentiate the denominator, and then what I have to do? Then I have to apply the limit there. Okay, yes. So let us see now how to do that. So limit x tends to 0 as it is. What is the derivative of tan x? Tan x is secant square x, isn't it? So secant square x whole divided by, now this is nothing but here root x. What is root x derivative? So we have certain derivatives. Tan x derivative is secant square x. Remember my logic, my trick, secant tan, cosecant minus cosecant cot. So there you are going to get that. And root x derivative is 1 by 2 root x. Okay, so here it will become 1 by 2 root x means who? 2x plus 4. Okay, then derivative of x is 1. So 1 into 2 will become 2. Okay, so here gets cancelled, and this minus 2 is there, right? So this derivative of 2 is a 0. Okay, so derivative of 2 is a 0. So now this root will join the numerator. So therefore this will become limit x tends to 0 as it is. This root will join the numerator because they are reciprocal in the denominator, isn't it? So it is 2x plus 4 into secant square x. So now apply the limit. Let us see whether we are getting the answer. So when you apply the limit here, x is 0. So this will become 0, right? So 2 into 0 is 0 plus 4. So 4 root. What is that root answer equal to? That is equal to 2 into secant 0. What is secant 0? Cos zeros 1, secant 0 also 1. So therefore you are getting the answer 2. And which is this option? This option is a D option. Okay. So I hope you have understood this. Is that clear? Yes? Okay. Yes, we move on to the next question. 23. Okay. So understand the question first. Let f be a function from closed interval 2 comma infinity to r. R is a real number, so real valued the codomain. Be the function defined by f of x is equal to x square minus 4x plus 5. Then we have to find the range of f. We have to find the range. So here domain is given, codomain is given. We have to find which among the 4 options will become the range for me. Okay. Yes. Now suppose, okay, so we are right, we have got f of x. F of x is equal to x square minus 4x plus 5, right? So suppose I call this as y. Now let me complete this, the completion of the squares. Okay, so how to get completion of the squares? What is the method? So x square minus 4x plus 5. Okay, so 5 I can write as 4 plus 1. Okay, so one way of doing that is I can write this as 4 plus 1. So 4 can be written as 2 square. So I can write that as x square minus 4x. Okay, so then we are getting plus 2 square and plus 1. So therefore this is nothing but a square minus 2ab plus b square. So a square minus 2ab plus b square is a minus b the whole square, isn't it? So it is x minus 2 the whole square plus 1. So this is my y now. Okay, so y we got as x minus 2 the whole square plus 1. So now I want what is the range. That means what is the, see, x the domain, it belongs to 2 comma infinity. What is the y values I am interested to find? That will give me the range, the image. Okay, so bring this plus 1 this side. So what is that you're going to get? You're getting y minus 1 is equal to x minus 2 the whole square. So how to get rid of this now? Square, you take a root. So therefore root of y minus 1 is equal to x minus 2. Okay, so what is the domain then? X is equal to minus 2. When it comes this side, it will become plus 2, right? So it is root of y minus 1 plus 2. Now understand this. If this one has to be, that is root, under this root, if this one has to be a real function, then under the root, what it should happen? Under the root, you should get a positive. Okay, so you should get this y minus 1 should be greater than or equal to 0. So what happens to 1 then? This 1 will go this side. So y is greater than or equal to 1. So which option satisfies? So y should be always more than or equal to 1. So since the equal to sign is there, we have to write the closed interval. So y belongs to closed interval 1 and more. So 1 comma infinity. So search the option where is the image belongs to. The image belongs to here. We have closed interval only one option, and that option is nothing but A option. So here we have closed interval 1 comma infinity. Is that understood? Is it clear? Okay. So we move on to the next question. Yes. So look at this question here. Now from this, that is the logic question, the mathematical logic, you will get 1 or 2 questions. You will get 1 or 2 questions. Okay. So what is the question telling us here? One is you may get the negation. They will ask negation, or second type of question which could be got is converse inverse contrapositive. Okay, so converse inverse contrapositive, right? Okay, so now here we have for all real numbers, so the negation, so negation can come in 2 different ways. So one is you will get and or. So how to write and or? So suppose you have a question like this, P and Q. P is one statement, Q is another statement. How to write the negation of this? So it is negation of P and Q. And is this symbol, okay, like a without a dash in between, P and Q. So when you have and or, then what happens will be change here, and change here. So therefore it becomes negation P and will become or will become and negation Q. So this is the procedure when you have and or. But if you have if then statement, if some P value is there, P statement, then Q is there. So how to find negation for this now? So whenever you have if then, the procedure goes like this. So what you do, cut the if, write till the word then as it is. Cut the word then, write and write the negation for the remaining. So it is negation Q. Okay, so simple it is when you apply this logic of mine to the questions which is given. Now here, coming to this 24th question, what is mentioned? This question also is asked us to find the negation. Okay, so find the negation. So therefore, so what is that negation of the statement given? Okay, so here we have for all real numbers. See, the word is given for all. Okay, so for all given numbers, yes, correct, Advait. Okay, so for all real numbers x and y, x plus y is equal to y plus x is. So what is it? A, B, C, D is there. So first one is telling us for sum. So for all, the negation of that we have to tell it is for sum. Okay, and what has been told for all the real numbers x and y, x plus y is not x plus y is equal to given. So how to tell the opposite? No, I'm telling the opposite. So what is it? X plus y not equal to y plus x. So here we are having the B option which is satisfying. Okay, so in addition I have told you if and is there, if then is there, how to get the negation answer. Okay, so I hope yes, I hope yes you are also getting the answers. Good. Yes, Advait, B is the right option. Good. Yes, you can get 50 plus in KCET. Only one thing I can tell you is, Advait, you have to solve all the question papers from 2014 to 2020. Okay, so 2020, all these. So you will get the ideas of how to solve the questions. Okay, so how the questions will appear. Okay, so how the questions will appear, and based on that you do whichever chapter is having highest weightage. So I've given that also in the YouTube, so just go through that. So whichever chapter is having highest weightage, so you can concentrate more on that to get more than 50 marks. Okay, so coming to the next question, question number 25. Okay, so now this is a question on the inverse trigonometric functions, and inverse trigonometric functions we should know the properties of inverse trigonometric function. So what is the property? What we have to find out, let us read the question carefully. The value of cos of sine inverse pi by 3 plus cos inverse pi by 3. Pi by 3 means how much? 60. Okay, so we want the value of, so we have to find cos of sine inverse pi by 3 plus cos inverse pi by 3. Okay, but what is the property? I know the property of inverse trigonometric function tells me, okay, so the property of inverse trigonometric functions tell me that is sine inverse x plus cos inverse x. So it can be any two co-functions inverse, that is sine inverse and cos inverse are co-functions, tan inverse and cot inverse are co-functions, secant inverse and cosecant inverse are co-functions of each other. So sine inverse x plus cos inverse x. So whenever we have, and one thing more to remember is this x and this x has to be the same. It should not change. Okay, so both has to be the same. So sin inverse x plus cos inverse x, then immediately we get the answer pi by 2. The question reduces faster. Okay, so let us apply this property in this question. So what is that we are going to get? We have sin inverse pi by 3 plus cos inverse pi by 3. So both in the place of x it is pi by 3. So this satisfies my property. Okay, the condition to get the property for pi by 2. Okay, so yes, so therefore since it is equal to the same property, sin inverse x is same, I can write sin inverse pi by 3 plus cos inverse pi by 3 as pi by 2. So now what remained? You got cos pi by 2. And what is cos pi by 2 value? Yes, so cos pi by 2, what is the option? Option is not A. Cos 90, sin 90 is 1. Cos 90 is what? Cos 90 is 0, isn't it? Cos 90 is 0. Sin and cos are opposite, isn't it? So sin 90 is 1. Cos 90 will become 0. So therefore, this is equal to 0. And which option that is? That is nothing but the D option. So it is D option. Hope the ideas are clear. Yes? Hope you have understood. Okay. Yes. So coming to the next question, we are moving to the question number 26. So coming to question number 26. Yes. So what is this now? This is a question from relations and functions chapter. Very important. Okay. So very important. So this is relations and functions topic. Yes. Okay. So here we have, if a relation R on the set 1, 2 and 3 be defined by R is equal to 1, 1. Now, I have to find out whether R is, see the A option, reflexive and transitive, symmetric and transitive, only symmetric, reflexive and symmetric. What you all say? Which one you want me to repeat? 25th or 26th one? The previous one or this question you want me to repeat? Okay, so let me explain to you. No, you understood, right? Because we got there in the previous question, we got this as cos 90. Don't get confused with the values of sine. Sin 90 is 1. Okay, you gave me the option A, which was 1. That is for sin 90. Now here cos is there outside. No. So cos 90 is 0. So that was D option. Okay. So now come to this question. Interesting question once again. Now, here we need to understand first of all what is a reflexive relation, what is symmetric relation, and what is a transitive relation. We need to understand this first. Okay. Yes. So okay, so here first let me explain to you and then come back quickly to this question. Okay. Yes. So now suppose we have we have a 3 element set here. So the set is 1, 2 and 3, which is given 1, 2 and 3. Okay. Now when we say a function R, a relation becomes reflexive. When is R reflexive? Tell me, what is a definition for a relation to become reflexive is, see, if A belongs to the set A for every element, that means 1, 2 and 3 is there. For every element that A comma A has to be present in R, this is the symbol for every. For every A belongs to the set A. Very important. Now that means if it has to become reflexive, then what should happen? For every A belongs to the set A means in the A set, who all are there? 1 is there, 2 is there, 3 is there. So if a relation R has to become reflexive means, according to me here, because of the word for every, 1, 1 has to be there, 2, 2 has to be there, 3, 3 also has to be there. But if any one is missing, that means you think 1, 1 is there and 2, 2 is there, 3, 3 is not there. Still I can say it is not reflexive because it is going against this condition of for every. Is it understood? So for every means how many ever elements I take in the set, every element, same element A comma A has to be present. Okay. Now coming to the second one. Now when we say a relation is said to be a symmetric relation. When we say a relation is symmetric relation means what? If A comma B is there in R, then its opposite also should be there in R. Okay. So now here we are checking in the relation, not all the possibilities. Okay. So here that means what is the condition for symmetric? If A comma B, that is if this condition is there, then only you have to check. If condition is not there, you don't have to check. Okay. So if A comma B is there in R, then its opposite, that is B comma A, also should belongs to R. Okay, but if here we can't say 1 comma 2, now in this particular I have 1 comma 1 only. Okay, there is only 1 comma 1, so search only for 1 comma 1. Who is the opposite of 1 comma 1? Same 1 comma 1, and that is there. Okay, yes, so reflexive, and you understood reflexive means what? For all, that is very, very important. For all the elements, same element has to be there present in R. Symmetric means what should come to your mind? If A comma B is there, then B comma A also should be present in R. So that is symmetric. One more thing we have, transitive. This is very important and it plays a very important role now. Okay, so what is transitive? Tell me, what is transitive? If A comma B is there in R, and word is very important, that is if A comma B is present in R, and this is important, and see where you have stopped now, at B. Okay, A comma B, you stopped at B. Now start from B, and B comma C belongs to R. Then what should happen? Then first and the last. Okay, first and the last. According to you, it is D option. No, it is wrong option. Okay, so A comma C should belongs to R. A comma C should belong to R. Okay, so now by chance this condition does not happen, that is I don't have the connectivity at all. A comma B, from B there is no other ordered pair at all. That means what I should do? By contradiction, I accept the transitive property. See, the condition I can check only when the ordered pairs are there in relation. No, if the ordered pairs are not there in the relation, how am I to check the relation? Not possible. Okay, are you getting the point? So now I'm coming to the question. So the question which is given is A is 1 to 3 is mentioned here, and the relation R is given to us only one ordered pair 1 comma 1. Now I'm asking you whether it can be reflexive. Can it become reflexive? It is not reflexive. It is not reflexive. Why? See, it is going against this condition of for every. I have there in the relation only one ordered pair 1 comma 1. Where is 2 comma 2? Where is 3 comma 3? Not there. So it cannot, this relation cannot become reflexive. So reflexive, no, it cannot happen. Okay, next, check for symmetric. Okay, so check for symmetric. What is the symmetric condition I told you? You have to check the ordered pairs in the relation. If A comma B is there in the relation, then only its opposite should be there. Okay, so I have only one ordered pair in the relation, 1 comma 1. What is the opposite of 1 comma 1? 1 comma 1. That is there. So therefore, this relation satisfies the symmetric condition. It is symmetric. Come to transitive. Now for transitive, what is the condition I have told? A comma B belongs to R and B comma C belongs to R. Then only I can check the first and the last element A comma C belongs to R. Now tell me one thing. Do you have the condition for transitive? Condition itself is not there. Then what did I tell you? If condition is not there, then by contradiction, I accept the transitive property. I say, yes, it is transitive. Why? Because I don't have the ordered pairs A comma B and B comma C. I don't have it at all. If condition is not there, from where to check? So in that cases, always remember, this is important point you need to understand. So in such cases, when the condition is not there to check, by contradiction, you are accepting the transitive property. Okay, so therefore it is becoming transitive because the condition is not there. Now which option satisfies? It is symmetric and transitive, so therefore it is B option which is satisfied. Have you understood? See, this is the, for transitive condition many students do mistake over here. Okay, so I hope you have understood the explanation which I have given to you. Yes, okay, yes. So we move on to the next question, question number 27. Okay. So what is given in the question number 27? If A is equal to A, B, C, a 3-element ka set, okay, then the number of binary operations. They have asked us number of binary operations. How many binary operations are possible? Okay, so I have a shortcut for you. Okay, so I have a shortcut for you. We will solve the question because I can't sit and list all the binary operations. Okay, so I have a shortcut for you, and the shortcut goes like this. If number of elements, so if number of elements in the set A, number of elements in the set A is equal to n. Suppose there are n elements in the set A, then the number of binary operations, will become n to the power n square. Understand this, it will become n to the power n square. Now come to the question. So come to the question. In this question, A is equal to A, B, C. So how many element set is this now? 3-element set. Okay. So yes. So we have, yes, very good. So we have 3-element set. So 3-element set means n becomes my 3 here, no? Yes. So what is the option now? Which option satisfies? So what is my number of binary operations? So therefore, the number of binary operations on A. Therefore, the number of binary operations on A is equal to n. N is 3 to the power n square. So 3 square. So how much is this now? First you have to find the square there, 3 square, find the power. So therefore it becomes 3 to the power 9. Very good. Yes, so 3 to the power 9. So therefore it is the C option. Did you get this answer? Yes, got the ideas? Okay. So remember the shortcuts always, okay? Yes, so we move on to the next question, question number 28. Okay, so what is the question number 28 telling us? So this is from the probability chapter. Okay, yes. So if A, B and C, there are 3, okay, 3 events are three mutually exclusive. So mutually exclusive means what should come to my mind? Tell me, what is a mutually exclusive meaning? Mutually exclusive means there is no intersection. Intersection becomes 0. Okay, and exhaustive events. Exhaustive means what? When I add all the events probabilities, it has to become equal to the sample space, which is 1. Okay, so which is equal to 1. Exhaustive events. Okay, mutually exclusive means no intersection. So the intersection, mutually word means between the two. Mutual word means between the two. That is between A and B, B and C, A and C. There is no intersection. And exhaustive means nothing but A union, B union C. Its probability will become equal to 1. Okay. Yes, its union is sample space and the probability here we are speaking about, which is equal to 1. Okay, the total probability is 1, right? Okay, then what is given to us? Such that P of A, probability of A is equal to 2 times probability of B is equal to 3 times probability of C. So probability A, B, C are interrelated, which is given here. What we have to find? We have to find what is the value of probability of B. Okay, so first, since probability of B is asked, let us write A also in terms of probability of B. Let us write C also in terms of probability of B. Okay, so P of A we know that is equal to 2 times probability of B. Okay, so A I finished writing in terms of B. Now I want to write C in terms of B. Okay, so what is the condition given? 2 times probability of B is equal to 3 times probability of C. I want who is probability of C. Probability of C I want in terms of probability of B. Why? Because you've asked me probability of B question, right? Okay, so what is P of C then? So P of C is equal to 2 by 3. This is multiplication, so it becomes division. So 2 by 3 probability of B. So I have kept ready P of A, P of C, both in terms of P of B. So now which formula I'm going to use here? I know the addition theorem. Okay, so what is the addition theorem? What is probability of A union B union C? So probability of A union B union C is equal to P of A plus P of B plus P of C minus the intersection. First let me write the formula, then write the condition. B intersection C minus probability of A intersection C plus the intersection of all the three, A intersection, B intersection, C. So now, what is the probability of the union? Since it is total probability, it is 1 equal to, what is probability of A in terms of P of B? So that is 2 times P of B plus P of B, right? P of B only, plus what is P of C? P of C is 2/3 P of B. Then what about the intersection here? Mutual exclusive. So intersection here 0, 0, 0 and 0. So we have only this much. Okay. Yes. So 1 is equal to, you have 2 plus 1 is 3. So 3 plus 2 by 3 times probability of B. Okay. So how much is 3 plus 2 by 3? What is this answer? So this answer is equal to 3 3s are 9 plus 2. So you are getting 11 by 3. So here you got 1 is equal to 11 by 3 into probability of B. But I want the probability of B now. So therefore probability of B is equal to what now? It goes to the other side. It becomes a reciprocal of 11 by 3. Who is that? Nothing but 3 by 11. So which option satisfies? B option is satisfied. Okay. Yes, I will be back. Hope this is clear. I will be back with the next session. Yes, so I stop for now. Thank you so much for joining.